Hello everyone, hope you guys doing great. And in this video what you are seeing here an AI application for coronavirus detection system. So I built this application on the top of TensorFlow, an application of deep learning. So you can see here there are various images being displaying, and corresponding to each image subject is being displayed, and it also showing whether the subject is contagious or not. As the algorithm is running right now, you can see here most of the images of contagious subjects having some blurriness on x-rays, and this is because when the person is suffer from coronavirus showing the similar symptoms as shown in the pneumonia. So guys, for making things in more detail, I'm going to stop this execution and will show you the execution for single image first, and will later on I'll move for rest part of the video where I show you the data set and other things. So let's remove continuous execution with a pause time of 5 seconds and stop for a single image. You can see here an output for subject 383, and subject is contagious by COVID-19. Same for the other image. So let's see how the data set is look like. Basically, this is my test data containing 624 number of images. I put infected subject on one folder and normal subject on another folder at the same time. So for training purpose, I have used very large data set. But moving toward the training data set, let me explain you how the training algorithm is look like. I have used, but let me give you a briefing about it. Import TensorFlow. I have it is here. I load my all data set which is being put on the train folder. Thereafter, I split the data set. 10% data set I have taken for checking the validation accuracy. I import the Inception version 3. When I import the Inception version 3, it basically take minimum size of image 224. One is that means I'm taking the grayscale image. I converted all image in grayscale. When I open this image, open the convert. Basically, single band I've taken, because the X-ray images as I taken from internet sources, some are the grayscale, some are the color images. So I've converted all those images in grayscale. Once I load the model, I compile it, Adam optimization, I've taken the variable learning rate corresponding to validation accuracy. Once my model is being trained, I have evaluated the accuracy. It is showing the 99 point something accuracy. I have generated the light version for mobile applications, though it seems to be no use for now. My final train version being saved in the temp folder, version 1. From the temp folder, I have copied this model here. This is my train model, very lightweight. TensorFlow 2 is basically comes with many add-on advantage corresponding to TensorFlow 1, and one of the biggest advantage is the execution time of the prediction time. As compared to TensorFlow 1, the TensorFlow 2 pre-trained model having the prediction time much more faster than the TensorFlow 1. Right now I'm going to show you the power of this deep learning algorithm. This deep learning algorithm, I'm not using here GPU, so I put my OS environment CUDA visible device -1. -1 represent as I'm taking the CPU as in for execution. Why I'm using the CPU? So that I can show you the power of this algorithm. I've already shown you how the algorithm is working. Let me show you the sample, how much time it takes to execute all the tests, and what is the average time. So it takes couple of seconds. So after some time, you can see here it takes around 8.52 seconds. Detected 624 sample as I taken from, I start from 1, that's why it's showing 625. And for detection of diagnosis of one image, it takes around 0.013 seconds. That means 1 second it would be able to diagnose at least 70 to 73 images in a second. This is significantly high speed as compared to other existing algorithm I have ever seen in the prediction time. So guys, why I built this algorithm? Because the main advantage of this algorithm, if we empower the current technology with the deep learning technology, so with the limited number of doctor, these type of algorithm would be able to help them out, and they can do the task in very much with the accuracy of very high accuracy in a very less significant time that a human cannot achieve the performance. So this is the main core of this video. I hope you guys like this video, and I would like you to show the execution of one single image also, which is the normal one, because I've shown you only the uh, execution for the disease person only. So it is simple. I don't need to feed the path of here. I can go with the paste here, where I can just give the path here. Once I give the path, it basically open the image. Sorry, copy, paste. I can take any image, copy path. So guys, let's see what it says to a normal image. Let me make these things uncomment. So here you can see here I have taken one random sample of normal image, and you can normal, no sign of any viral infection. So guys, this is all about today, and okay, this will go going on like that. So so guys, I'm ending up here, and this is all about the algorithm and technology. This algorithm is having accuracy around 99.99%, because I haven't seen till now so many images I have tested. It is showing exact result. So because of the limited data set, I cannot say and I cannot claim anything right now. So, but if any person who can make this technology usable can see this video, will be help to say can help to save many people life. So guys.